Let's make a plaster jigger mold for a serial bowl shape using the Fusion 360 CAD design tool and 3D printing. Create a sketch on the YZ plane. Start at the origin and draw a 28mm line horizontally right. Next, draw a point and dimension its location 80mm to the right and 51mm up from the origin. This is the upper outer edge of the rim. It is the only point we will create. Next, draw a vertical line 7mm downward from the point and extend it leftward about 2mm. Draw a 3-point arc to join the horizontal line to the point. Make the arc tangent to the lower horizontal line to get a smooth inner contour. Then remove the unneeded line endings at the rim, bevel the two rim corners to 0.3mm, and set the horizontal distance between the points at 0.1mm. Draw a 7mm circle at the join between the line and the 3-point arc and remove all segments but the lower half. Then bevel the joins to 2.5mm. Remove the existing measurement and constrain the centre of the arc to 33mm right of an 0.875mm up from the origin. Finally, dimension the centre point of the 3-point arc to 53mm up from the origin. These constraints assure the integrity of this shape. Now I'll draw the jigger mould itself. I'll start at the point and draw straight lines horizontally right, then down, then left, then angled inward and down, then horizontally left, and then up to close the path. I'll constrain and dimension these to fit into our cup head. First, I'll set the last segment vertical, and then set the seat point angle to 115 degrees. Next, offset the rightmost profile by 0.8mm. Remove the unneeded segments and close it in at the horizontally at the top and bottom. Now, we have 2 dimensions to set. How we do that depends on whether your 3D printer is large enough to print this outer shell on one piece. Since our printer can print the whole 3D printed shell, it can stay on the mould for its service life. Our cup head requires 180.5mm diameter for the mould to sit tight within. Thus, the radius goes horizontally from the origin to here, 180.5 divided by 2 or 90.25mm, and the step width of 3mm goes here. However, if your printer is too small, you will need to print the shell in 2 halves. They will be removed and can be reused. For that, set the 90.25 dimension to go to the step inside the wall, and the 3mm step inside also. Next, let's make the template. First, draw a 12mm horizontal line, starting vertically up from the point. Dimension it 0.25mm up. Then draw a 5.6mm arc leftward from the same point and constrain its end and centre horizontal. This is the lip of the bowl as shaped by the template. Now draw the inside bottom as a horizontal line, starting from the Z-axis, extending to the foot ring. Dimension it 5mm up. Then draw a 3-point arc to join its end to the rim arc. As with the other, make it tangent. Finish by adjusting the horizontal position of the join to get even wall thickness. Next, draw the upper part of the template. The lines do not need to be constrained as the shape needs to be adapted to the metal mounting plate on the jigger arm. You will likely need to make holes of the needed size and relative geometry to match the mount on the jigger. This enables moving and rotating them as a group. The next steps assumes that we want to pour a solid plaster model of the bowl itself to pour each working mould around it. This method enables tooling and soaping the plaster surface to achieve a much smoother result than is possible by 3D printing. To start, offset outward by 0.8mm all the segments of the profile. Fusion might offset more than needed. If so, just remove the unneeded ones. To achieve better rigidity for 3D printing, I will draw a new flat horizontal base and remove the inside unneeded parts. Finally, I'll remove the small overhang at the rim to eliminate the generation of support by the slicer. Now let's adjust the plaster mold shell in a similar way. This shell will stay in place on the working mold because our printer can do it in one piece. It needs to be printed upside down, so to avoid the need for support, I'll draw a line segment to bypass the inside step. This thicker section will also impart rigidity to keep it absolutely round. Next, draw a horizontal line, about 1 millimeter down from the point, from the bowl profile rightward. Extend it past the outer edge, then upward and left to join the corner. Dimension the line down 1 millimeter and the flange extending 5 millimeters. This flange enables using a clamping base plate. I will also add a small 1.2 millimeter wide, 4 millimeter drop down from the top edge, midway across the top. This will anchor it into the plaster. If your printer is small, then you need to print this largest section in 2 halves. This requires that addition of a flange. By inserting it now, this drawing will have the flexibility to do it both ways. Start on the far right of the sketch, draw the segments approximately and set the 5 millimeter wide measurements and parallel and horizontal constraints as needed. Now, let's create our first 3D body. To do that, I need to finish the sketch. Note that you can come back to edit the sketch by right-clicking it on the timeline and choosing Edit. The panel can be hidden when needed. I am using the Revolve tool and carefully selecting all parts of the profile, including the step bypass and the upper-outer flange. After picking the axis, it's done. Remember that this one is to be printed upside down. The wide top flat section will stick it firmly to the bed. Now I'll hide it in the browser to do the next one. Next, let's revolve the half shell. This time I am choosing a different set of shapes. Don't bypass the step. Include the wide vertical flange and include only the outer top horizontal flange. Then select the axis, set the extent as partial and the angle to -180 degrees. Now let's revolve again, but use the cut operation. Select only the flange, select the axis, the direction to 2 sides, and set the angles at -179.3 degrees to 0.7 degrees. This produces 1.2 millimeters wide vertical flanges. 3D print 2 of these shells upside down. Be sure to configure the slicer to generate support for the step. Now hide the half shell in the browser and let's do the same with the shell for pouring the model. Be careful to select every section needed and set the extent back to full and the angle to 360 degrees. Next, I'll hide this to get ready to rotate the spacer ring. This ring serves to center the model within the outer shell and hold the latter perfectly round. The way we do this depends on whether you need to print a 1-piece or 2-piece outer shell. For the half shell, select all 4 areas. For the full shell, just select the inner 2. Finally, choose the axis and finish. The last item is the template. Let's first extrude it 1 centimeter thick. Now let's angle the bottom cutting edge to 45 degrees using the draft tool. Select the backside as the pull direction, then the bottom edges and then set the angle and finish. When printing this, use an infill of about 15% for testing first. Even working templates likely do not need to be printed solid. To finish, I have reorganized the 3D objects we have created by making them all visible, hiding the sketch, and arranging them using the Move tool. The technique we have just used could be adapting to make a wide range of shapes for jiggering. Thank you for watching.